Hello, dear children. In our previous class, we were doing practice set 1.3. We will continue it, but we will just revise the test of similarity of triangles and then we will continue. So, the three tests of similarity of triangles are AA test of similarity, SSS test of similarity, and SAS test of similarity. AA test means angle, that is, if two angles of two triangles are congruent, then the two triangles are similar by AA test of similarity. SSS test, if all three sides of the two triangles are proportional, that is, they are in the same ratio, we can say the two triangles are similar by SSS test of similarity. Third one, SAS test. That is, if two sides are proportional and the included angle is congruent, then we can say the two triangles are similar by SAS test of similarity. Let's continue with our practice set 1.3. Sum number 6. In trapezium ABCD, AB is parallel to DC, diagonals AC and BD intersect in point O. If AB is 20, DC is 6, OB is 15, find OD. Now, how do we do it? We are given a side AB parallel to side DC. Remember, whenever two sides are parallel, the alternate angles are congruent. Now, what we have actually to do here? We have to prove two triangles to be similar, then write the corresponding sides, and only then we can substitute the values. So, which are the two triangles that we have to prove to be similar? That is depending on what is given. Side AB is parallel to DC. So when side AB is parallel to DC, we know that angle ABD congruent to angle CDB because they are the alternate angles. So let's write down side AB parallel to side DC and therefore angle ABD congruent to angle CDB. Now look at the figure. Angle ABD can also be written as angle ABO because points B, O and D are collinear. And same way angle CDB can also be written as angle CDO because the points B, O and D are collinear. So we'll write angle ABO congruent to angle CDO because the point B dash, O dash, D. Now we will consider these two triangles, that is triangle ABO and triangle CDO. We will consider triangle ABO and triangle CDO. Now we will write this first step, that is we have already got angle ABO congruent to angle CDO from 1. Now we can see the vertically opposite angles here. Angle AOB congruent to angle COD because they're vertically opposite angles. So let's write down, and the reason will be vertically. Now two angles of both the triangles are congruent and therefore the triangles are similar. Therefore triangle ABO similar to triangle CDO. The reason will be AA test of similarity. When the two triangles are similar, we can write the corresponding sides, that is AB upon CD is equal to BO upon DO is equal to AO upon CO, and the reason will be corresponding sides are proportional. Now, let's substitute the values. AB is 20, DC is 6, BO is 15, find DO. So, we will substitute the values in the first two ratios. Third ratio, we will not look at it at all. We will put the values in the first two ratios. Now, OD is equal to 15 multiplied by 6 upon 20. So now OD we get it to be 4.5 units. Write the final step, OD equal to 4.5. This is how we do sum number 6. Let's move on to number 7. Quadrilateral ABCD is a parallelogram. Point E is on side BC. line DE intersects ray AB in point T. Prove that D into BE is equal to C into T. Now, here we are not given that the sides are parallel, but we are given that quadrilateral ABCD is a parallelogram. So, quadrilateral ABCD is a parallelogram means AB is parallel to DC. That's what we mean. So, let's write the first given. Yes, I have written point E is on side BC, so I wrote it as B dash E dash C. D intersects ray AB in point E, I wrote it as this. To prove is D into B is equal to C. Now, we will write down quadrilateral ABCD is a parallelogram as it is given to us. And therefore, we can say AB is parallel to side AB parallel to side B. That is, opposite sides of a parallelogram are parallel. Now, AB is parallel to side DC means AT is parallel to DC because the points A, B and T are collinear. So, we can say therefore segment AT parallel to side DC. Now, two sides are parallel means the alternate angles are congruent. So, AT is parallel to DC means angle ATD is congruent to angle TDC. That is because the alternate angles are congruent for the transversal TD. So, let's write down ATD congruent to angle TDC, alternate angles for the transversal. Now, therefore, we can say angle ATD can also be written as angle BTE. Angle ATD can be written as angle BTE because it's angle T we are talking about, therefore angle BTE. And same way, instead of TDC, we can say angle CDE. Now, put it as 1. Now we will consider the two triangles. That is triangle BT and triangle CD. So here we have got angle BT congruent to angle CD. So we'll copy it down. Yes. Now, here if you look at the two triangles, you can also see angle BT congruent to angle CED, the vertically opposite angles. The reason is vertically opposite. Therefore, two triangles are congruent, and therefore the two triangles are similar by AA test of similarity. When the two triangles are similar, we can write the corresponding sides, that is BT upon CD is equal to T upon D is equal to BE upon C. Then the reason will be corresponding sides are proportional. Now, we need to prove DE into BE is equal to CE into TE. Where this comes. Look at the three ratios. Where will we get it? DE into BE, which means it's a second and the third ratio. That is DE into BE will be in the second and the third ratio. So we will not take this at all. So depending on what we need to prove, we have to choose the ratios, that is T upon D is equal to B upon C. We'll write it down and then we'll cross multiply. That is, we will get DE into BE is equal to CE into TE as the question is. This is how we do number 7. Let's move on to number 8. In figure, segment AC and segment BD intersect each other in point P, and AP upon CP is equal to BP upon DP. Prove that triangle ABP is similar to triangle CDP. So, first of all, let us write the given. As it is given, segment AC and segment BD intersect each other in point P, and AP upon CP is equal to BP upon DP. To prove is this. Now, proof. We will consider these two triangles, triangle ABP and triangle CDP. So, the first step will be in triangle ABP and triangle CDP. Now, let's look at the triangles. we are given triangle ABP and triangle CDP. Can you see the vertically opposite angles? So we can write angle APB congruent to angle CPD. And the reason will be vertically opposite angles. Now, the two sides are given to be proportional. Can you see the two sides? AP upon CP is equal to BP upon DP. So I'll write down that also. The two sides to be proportional and given. The reason will be given. Now we have got one angle to be congruent to another angle of the other triangle and two sides to be proportional. Therefore, the two triangles are similar by SAS test of similarity. Let's move on to the next one, which is the last one. In the figure, in triangle ABC, point D on side BC such that angle BAC is equal to angle ADC, prove that CA square is equal to CB into CD. My dear children, what has to be proved? CA square is equal to CB into CD. So let's write first the given. Yes, point D is on side BC, so I'll write it as B dash D dash C. In triangle ABC, B dash D dash C and angle BAC equal to angle ADC as it is given. To prove is CA square is equal to CB into C. We have to prove CA square, which means CA is here, which means the two triangles that we are going to consider for similarity should have this CA in both the triangles. So which are the two triangles? Here I can see three triangles, triangle ADC, triangle ABD and triangle ABC. Both the triangles should have AC means I should say the two triangles we need to consider will be triangle ADC and triangle ABC. Triangle ADC and triangle ABC. So let's look at what is given. Angle BAC is given to be angle ADC. So we'll write accordingly in triangle BAC and triangle ADC. So let's write the proof. In triangle ABC, BAC and triangle ADC, we can say angle BAC is equal to angle ADC given. Now, look at both the triangles, triangle BAC and triangle ADC. Both the triangles have angle C, which is a common angle. So we'll rearrange and we will write down angle BCA is congruent to angle ACD. The angle C should be at the center. And so BCA is equal to angle ACD and that's a common angle. Therefore, the two triangles are similar by AA test of similarity. Now, when the two triangles are similar, we can write the corresponding sides. BA upon AD is equal to AC upon DC is equal to BC upon AC. And the reason is corresponding sides are proportional. Now, let's look at what is to be proved. CA square is equal to CB into CD. Let's look at which ratio we will choose. CA square, yes, it comes in the second and the third, AC. So we'll choose these two ratios. AC upon DC is equal to BC into upon AC. We'll write it down and then we will cross multiply. AC square is equal to BC into DC. Now the question asked is CA square is equal to CB into CD. So we'll rearrange this and write as the question is asked. CA square is equal to CB into CD. This is how we prove number 9. With this, we complete our practice set 1.3. Keep practicing. Thank you. That's all for today.